All right, my name is Stefan and I work here at Projectplace as a backend developer. But since my fingers are kind of sticky, I'm in all the R's now. So I'm actually a bit involved with the infrastructure as well. So I will talk a bit about how we moved from Windows to Docker. And so I will talk a bit how we did it and what steps we took along the way, and all the tools we actually used to make it happen. First question then, why Linux? Well, several reasons. We are a Python shop here, so we actually do everything in Python. And Python on Windows is, it works, unless you need some special modules that you actually need to compile. Then it's a huge mess because each of them use different versions of Visual Studio. And it's just a few people here that actually know how to compile them, which is a huge bottleneck. So we ended up not upgrading some modules due to that. And that doesn't work. Another reason is fast CGI. It's an old application server, really old. I don't think it has been maintained in 7 years or so. And so we were riddled with bugs that we actually had to patch ourselves. And that we actually had some downtime due to it during some circumstances. So we needed to move away from that. And our developers, most of them actually use Apple today and OS X. A few still run Windows and some run Linux. So it wasn't a perfect environment to actually make sure everything worked as it should. And there are several other reasons why we want to move to Linux. I mean, maintenance of Windows is also a huge mess, so it's easier with Linux. So we had to do some type of proof of concept. Would our service actually work in Linux to begin with? It's been in Windows since '98, so I mean it's a lot of legacy in there. So the first thing we had to start working on was actually a way to move away from the SQL driver, the SQL driver that we used in Windows, called ADODB. So we had to make sure we could simultaneously run two different drivers. One that actually work in Linux, because ADODB does not. So actually before this project started, that was evaluated and work began testing the code with PyMSSQL. We are still running our database in Microsoft's SQL server. So we haven't moved away from that yet. Someday we will, might. We also had to migrate from Python 2.6 to 2.7, which could be problematic, but we had to test it. And then is the case-insensitive problem. Oh my God, we have huge problems with that in the beginning. Nothing worked, we couldn't compile anything. It was a huge pile of crap, really. We also did a lot of logging to local files for everything, access to output of test runs and pretty much everything. So we had to go through all the code and actually start logging to a central server. So we choose Elk for this, of course. So everything is logged there now. So that was part of the proof of concept. We knew we had to do something. We picked UWSGI as the new application server, which is a quite well-known application server for Python and other languages. Actually, it works with Ruby and a lot of other types as well. So we picked that one, and we actually had to go through all the legacy configuration in Apache with FastCGI and port it over to a format for UWSGI. That was interesting. A lot of issues there to begin with, but we managed to solve them all. One good thing was that we actually used Apache on Windows, so the transition to Apache in Linux was quite little, so that was a positive thing. And then there's the case of configuration. We needed a way to maintain two types of configuration, one for the Linux environment and one for Windows. So we came up with a template-based system for that could replace things that path and how a path should look like in Windows, etc. And we picked Ubuntu. Maybe not the best Linux distribution, but they have a sane release cycle. A lot of other distros has, they half-a-year releases, and yeah, doesn't work. We want one we can rely on for a bit longer than that. And I know some might say, why didn't you go with Red Hat? Well, we don't like to pay for free stuff when we don't have to. Yeah, so, well, everything went quite well. We had some initial issues with how Python actually shares state when it's running in an application server, which caused nasty seg faults at the times, usually when under pressure, when things started stepping on each other. And there was a hidden feature in the UX guide to turn that off. And we had to search quite a bit and running a lot of GDB debugging on this to actually find out that there was an option to fix this. So yeah, that's what the eureka moment when we found it. Everything just started working. So you go, woohoo! So we have a go. We also use the PyMS SQL driver, as I told you earlier. And of course, there were issues there as well. That driver is, well, they haven't released the driver in 3 years, I think, but they are committing stuff every day on the master, but they haven't done a release in 3 years, which was kind of scary. But we took that code and fixed things, and now it's running and it's working quite flawlessly, I'd say. Yeah, and front end, yeah, we had issues there, and mainly because we had to do some main jumps in NPM and Node.js things, which didn't work with the build system we had. It was kind of old, so we had to rebuild that from scratch yet again using Gulp. So we did that transition as well. So there was a lot of key things to actually fix before we could say, yeah, let's move ahead and move to Linux completely. Our unit tests, we have quite many. I think we are around almost near 7,000 unit tests right now. So they actually helped us find the key issues between Windows and Linux. And then some test was kind of stupid, doing relying on local settings for the system. So Windows local, it expected some sort order that Windows provided. And well, that didn't work in Linux, of course, because it wanted to sort something differently. So we fixed those tests and removed it because it wasn't valuable. So yeah, well, in the end, it worked pretty well. We did this proof of concept in about a month, rewriting all this, and yeah, we think we could continue actually going to production with this. So we got a go for the project. We went through and did it in three phases. We started with development and moved on to testing, and then, of course, production. So how do we get this out to the developers? We knew Docker was around the corner. It actually was released 2 months before we started the project. So in July, .0, I think, was released of the Docker. So we thought, whoa, let's see if this can be a solution to our problem. But this would still require a bit of work for each developer to actually set up Docker locally on their computer. And yeah, everyone isn't that happy running Homebrew or whatever. So we wanted a way to actually fix that for the developers and make it easy. So we created a tool for that, of course. We named it pptool, Projectplace tool. It's actually a local Docker orchestration engine, more or less. I will, if we have a few minutes over in the end, I will actually demo it. But you actually just curl it and pipe it to bash, and it installs itself. And you run a few commands, and if you have a Macintosh, it will actually install Parallels. It will vagrant boot an Ubuntu image, and it will put Docker on it, and it will download our Docker images and start them in the order they are required to run, and with all the parameters. So they run pptool up, and they have a complete development environment running. Usually it takes less than 10 minutes. And in Linux, it's even simpler because you only have to install Docker more or less, and it's up and running. One good thing with this approach is that the images we build, they are used in production as well as in development. So we know the image they are using to do the day-to-day work actually works. So testing. Yeah, During the phase where we actually had to move from Windows to Docker or Linux, we had to run the both environments simultaneously. So we had to create in our pipelines a way to deploy to both Windows and Docker. So it was possible to actually do some online testing through our browser and see that, yeah, things are behaving as we expect in both environments. We had some orchestration needs, of course, as well. So we started evaluating Kubernetes first, but we soon ran into issues with that one. It didn't handle shutting down and moving images or containers in a graceful way. It actually just killed them and up with another, because you have 3 running, so I can kill 2. That's okay. At least in the early version. I hope it's changed now, because that was unusable for us. We also tested Helios and ran into the issue that you couldn't have the multiple images. Another failure. So we decided let's roll our own. And that's what we did. So we created a library called Docking Bay, which is just a smart library that does some cool things with etcd, which is a key store for information. And wraps that together with DockerPy, which is a well-known Docker API to actually run things on the Docker. So we expose the Docker API on all our servers currently with the client certificates and all that, so it's safe at least. Nice etcd is actually our own implementation of a Python etcd library. We used some out there, but most of them have some issues with clusters. And we decided not to patch them because they have some design flaws we didn't like, so we built our own there as well. And we chose CoreOS then to actually run our Docker infrastructure on, with a few customizations. I will get to the details, but we actually put in PyPy, which is a lightweight Python binary, which we put in the init image. We actually boot our servers from the network and actually run them entirely in RAM memory. No state on the hard drives in the servers, which is pretty cool. I will talk a little bit more about that later. We also insert the VM tools. I know that if you get the image from CoreOS for VMware, you get it included. But if you want the TFTP version of CoreOS, they don't include VM tools. We wanted to run it on virtual servers as well. So we put that in on the fly automatically by just verifying some signatures from CoreOS for every release. So when they release a new one, we have that one. It's downloaded and patched automatically. So production, just a very simplified view over our current production environment and the flow of things. We have a few other tools here that I didn't mention. We have the Admiral, fitting name, I think. That's our orchestration engine. It does some clever things. So when you boot a CoreOS machine, it fetches stuff from DHCP and TFTP. It also downloads a cloud config, which I think we abuse the cloud config pretty much. We do everything with it. We actually start Admiral inside one of the CoreOS servers as well. So it's running Docker, but it's not visible here. It's actually inside a Docker itself. But it's bootstrapped through cloud config. So what happens then? We use, I'm not sure how many of you have used CoreOS, but it has a little daemon called Fleet, or FleetD, which is responsible for registering itself in the etcd cluster with some information about itself, and it does keep alive to update the value. So if it stops updating that value, it becomes stale and removed from etcd. So we utilize that to actually know which servers are active in our cloud, so to speak. But we also let our service provide metadata about themselves. So we have a IP management system where we can assign different tags to a server. So it could be, yeah, this is an application server, this is a RabbitMQ server, or whatever. and we can have multiple tags. So the moment it starts up, it registers itself in etcd with that information. And then it's the admiral's job to actually discover changes in etcd. So it notices, oh, a new server with the metadata tag application server. Okay, this application server should have these containers running. So it immediately goes to the Docker server by getting the IP from the etcd, connects to the Docker API endpoint, and checks, do you have these containers? No. Okay, so it tells the Docker daemon to, well, download these images with these tags and start them up. Then Admiral also do a quick check, so we have some API endpoints to actually verify that the container is healthy. So it can run SQL checks and file storage checks, and so when that's okay, it will actually do another call to our load balancer and tell you, oh, on this port we have a container running with this information. It should be a member of this pool. It inserts it, and well, voila, the service in production, and the traffic is coming to it immediately. And another nifty thing about this, we had a faulty server with bad raw memory, which started to rebooting. It's self-healing, so the moment the server came up again, it was fixed and added to the load balancer again. So that's pretty nifty way to handle things. Yeah, I think that's about it about that. So continuous delivery, yeah, that's the key for how we do our release cycles. We have used GoCD previously for, could it be 2 or 3 years back, something like that. So we continue to use that, but we integrated Docker with it, of course. It fits very well. We really want the one-click deployment because it's easy for everyone. All developers essentially can just click through and enable if all tests have passed. So that's a good thing. We have loads of pipelines. I will show you a few images here. So this is what our GoCD looks like currently. There are a few more, not on the picture, but so on the bottom line there, that's all the Docker magic. So we have quite a dependency tree of Docker images, and they have to be built in certain order. But yeah, this pipeline handles all that and tests some of the things and make sure it's actually working in a good state. We have this test next here. That's actually our pipeline that does testing all commits from the developers. Every commit is built and deployed automatically without the interaction from the developer into our test environment. So they can test things immediately. And then we have the hotfix one, which is actually every Wednesday. We do weekly releases normally. So each week we merge the master branch into the hotfix, and then we can do bug releases during the week until next release. So this is what this hotfix track does. We usually have around 3 or 4 releases per day into production. So it's working really well. We haven't had any failure downtime yet. I hope we don't get one. We do rigorous testing, unit tests, and we run the smoke tests, of course, which is Selenium tests. So we actually test everything thoroughly. So if one of these steps fail, that image won't go further. Here you can see actually all the Docker, some of the Docker image being built, and actually moved around to different Docker registries, which we house here at Projectplace. And we actually have one in Bangalore, India. And that proved to be a challenge because we have developers there as well. We have 2 or 3 teams down there that needs to work with the same platform. So one thing we did here, because the internet connection there is crap. It's really, really slow. At least from the Stockholm office down there. So syncing images was a pain. It took doing a full sync of our Docker repository, which is about 3 or 4 gigabytes or something. Took like 8 to 16 hours. Yep, so that didn't work. So we came up with a pretty clever solution. we connected our Docker registry here in Stockholm to the Amazon S3 bucket, and created a clone from there down to Singapore. So every time you push here to Europe, it's Amazon syncs it down to Singapore, and India can pull from there, and we cut the time down to under an hour. So it's pretty amazing stuff. Yep. Yeah, so yeah, Docker to production, zero downtime, which is what this was all about. Since we tested our new Docker things locally on the computers for a couple of months, we had it in test continuously. We knew it actually worked. We didn't have many issues left. And when we did the switch, we actually just rebooted the Windows server, and the TFTP booted into Core OS, so the Windows server was intact during the test. So we could just reboot back into Windows and have it up and running again. So that was a good thing to do. Yeah, so then it was just about to disable the old servers and enable the new ones, let Admiral add them, and go. So that was it. So it was actually a total anticlimax. We hoped something would break, but didn't. We hoped that the customer would notice, but no, they didn't. Well, some did, because they noticed a performance increase. On the same hardware, we actually gained quite a bit of increases. The API, one customer came back, what have you done? Our times to do synchronization against your API is 4 times faster. But, well, we are running Linux now. So yeah, so it was, yeah, kind of cool. Yeah, all of this happened quite quickly. We started sometime in September and did POC for 1 month and moved on to creating PP tools to run Docker on the local workstation, and invited some extra users in the end of November. Put one internal server, production server in use, and told our load balancer to only take the office people to that node, so make sure it actually worked. We didn't tell anyone, and no one noticed that either. So that was how we tested. We tested on ourselves first. So, and that went well. So we put one out for the customers in February, and they didn't notice either. And then we decided to do some tweaks, and then we just exchanged all of the servers in April. So everything is running on Docker. And today we are actually on a revolution in our system. We have redesigned it again and made even more improvements. So it's even faster today on new hardware, and security is up a bit, because when we started this, it's what etcd.0.5, which didn't have roles or user access or anything. So it was quite open, even if it was internal and blocked by firewalls. It wasn't that secure. So today we are running etcd2 with role access and stuff like that, because the containers themselves ask etcd for its configuration when they start up. So that's how we solved it. Yeah, so do you have a few minutes? I'm going to just show you PP2. Yeah, and we can take some questions after that. This will be interesting. Yeah, oh yeah, if I can move the window. All right. And increase the size a bit. All right, I should do it, so I will just pretend you didn't see this one. I'm just going to simulate how it would work on if you were on a Linux platform. So this is the line all the developers get when they start working here or reset their computer or whatever they do. So that happens. And I will just see if I have that in there. I have it. All right, the tool is in place. As you can see, you can start images, you can down, and you can restart them, check status. You can get the shell immediately into a Docker container, and some other stuff. And of course, everything comes with a tab completion, So these are the containers we have today. And if I just run up, they might be up, so let's down them first. Okay, they won't. Great. Let's do it. Hard to type from the side. So yeah, I had a few running. And now something really failed because, yeah, sorry. Normally the first thing you do is you run install to actually set up your computer, and I forgot to do that, so that was stupid on me. So here we can choose from which office, which is nice. So this is actually a local mapping to run my code locally on my computer inside the running container, so I get real-time changes when I update code. So I input that here, and it will be mounted. And I have an instance because we have a few external databases. And let's see here. Yeah. Right. Hopefully. Yeah, so it's up and running. And you didn't see the other one because they actually was up already, but it starts them in order. So I could actually reach my local development environment now. So yeah, that's pretty much it. Any questions?